Hey everybody, my name is Jeffrey Koss. I am a student at the University of Advancing Technology. That was hard to get out for some reason. And I'm in a class for robotics. It's called Robot 173, and it is an introduction to microcontrollers. And for this assignment, I kind of had to build upon my previous assignment where I basically um, wrote code and designed a circuit for a small autonomous robot. Basically, just basic movements: forward, reverse, turn left, turn right, stop. Now I am going to introduce an interrupter uh, with an encoder that is an interrupter. I actually used it in the last assignment, but I didn't really get into it, so we'll get into it more here. These things are pretty cool. This kit came with two of them. I burnt one out, so my presentation might be a little watered down, and I apologize for that. But we'll get through this. Okay, so with an encoder, basically what it does is it's a sensor that can determine how much something is moved depending on whatever it's measuring. For this device, we're using a disc. It's like a wheel, and it has spokes in it. So there's pieces of it that are solid and pieces of it that are basically cut out and you can see through it. What happens is there's an infrared sensor in there, and when it gets tripped by the part that's closed, it goes low, and then when it opens, it goes high. Now you can set these to do different things. I have this set on rising, which means that it's going to count after the thing was closed and it's going from 0 to 1, if that makes any sense. So the unique thing about these things is you can get a lot more precise control over your autonomous robots by using something like this. So for example, um, if I were to just code things and use the hardware that I had, it would work, but it wouldn't be as accurate or as nifty as it would be with an encoder. So, for example, I can now make my turns very precise, whereas before, it was a lot of guessing and stuff like that. So here's how it works. Um, we use a long integer, volatile actually, long integer, called counter. Because this thing updates so fast, we have to have it volatile. Um, and with that, we have a counter. So it'll count. I can count how many times this thing rotates or how many times this passes a certain point with ease. I use it in this program to compare the counter with an integer called duration, which basically acts as a timer. And once it reaches that timer, it resets itself and moves on to the next part of the program. But in the future, I'm actually going to use this to be able to accurately measure distances and also like turning radiuses and stuff like that. So now I know you've seen my last video and you've seen the thing move, my robot car as it is right now. And you do know I blew out one of the encoders. The other one works, so we're going to get into this. So here's how this works. Um, you have to put the encoder on either pin 2 or pin 3 on the Adreno because those are the only two that can handle interrupts. When you do your interrupt, when you do your pin mode, you have to put the input pull up or use a pull up resistor. This will ensure that it starts off in the high state. Um, and then you have to basically attach the interrupt to the digital pin that you want. And then in the middle here, it's going to run a specific function that you want. Mine's easy. Mine just updates. It basically just increments the counter one every time it goes through and it's rising. I use this on every single function I have here. As you can see, while counter is less than duration, do this, and then once it's done, once it hits duration, go back to 0. So that's what I'm going to demonstrate today. Um, I do have one that stop robot that doesn't have an I use delay. But here's the function, update coder. It's real simple. It's just one line, counter plus plus. Okay, so let me hook this robot up here, and hopefully it works. It's a little finicky because I don't have anything soldered together yet. So it can be a little tricky here. Let's see what we get. Okay. Oh yeah, it's working all right. Okay. So going forward, so there's your encoder working. It's updating every 750 milliseconds. Going backwards. Once it reaches 1,000. Oh wait a second. Wait just a second. Guess what? Guess what? I need to do something really fast. I need to upload this code because I changed the duration to 1,000 so you can see it working a little better. Okay, there we go. So now you can see that every so many milliseconds, I think it's 750, I'm getting a reading, and it's pretty accurate. So this is going to take a little bit longer because I'm using pulse width modulation, and I slowed it down in reverse. Now we're turning left. That's neat. I think that's awesome. Turning right, and yeah, now we stop. And it's just going to repeat itself. I'm impressed. It's too bad I blew out the other encoder because I could have used it for other things, a little bit more precise. But I think, we can make do with what we got here. Anyway, that's my presentation, and I hope you liked it. Thank you very much. Have a great day.